Okay, so can you give a brief, like 1 minute overview about like who you are, where you worked, maybe where you went to school, years of experience, how much really code have you done, anything you think is like relevant?
Yeah, my name is Adi. I've been an L5 at Amazon for some time, for about 3 years. Before that, I was in a non-fan company for another 3 years. So total 6, 7 years of experience. And yeah, I was impacted by layoffs. So I'm going to practice more and try to see what kind of water I'm in.
Cool. Okay, yeah, so I guess you're interviewing for like mid to senior,
Yeah.
most companies. Okay, cool. Okay, so I'm gonna give you the problem description up here.
Mhm.
And I think for this one, it will be easier if I just paste the problem statement. If you've seen it, let me know. I can ask you something else.
Okay.
Yeah, take your time
So,
reading it and let me know if you have questions.
right. Okay. Design a data structure to use to store strings count with the ability to return the strings with minimum and maximum counts. Okay. All one class, initialize the object with whatever data structure, and then string as an input increments the count of the string. Oh, okay. So it's a cache kind of a thing. Key does not exist. Insert it with one. Decrement it. Makes sense. Count of key is 0. Remove it from the data structure. And either the key exists for the okay. So is this statement removing it from the data structure? Is this a suggestion or because if I mark it separate in a different way, is that fine instead of removing it?
Yeah, if you fake removal or dummy removal or
Yeah,
whatever, like as long as everything else works, that's totally fine. Yeah.
yeah. Okay. Then one of the keys with the maximal count and the max key with the maximum count. If no element exists, return empty. Min key returns one of the keys with the minimum count. And if no element, okay. Must run in O1 complexity.
Mhm.
That is fine. Um, okay, so because we need, so this is like how I'm thinking of cache, but obviously cache is more nuanced.
Mhm.
But I understand that given any string, uh, because of cache, I'm thinking of dictionary or hash maps. So given any string, I store the string as key, and then the value is forever incrementing as it comes along. And what we need to keep track of is the key which has the maximum value. One way I can think of is like a global maximum and minimum. Um, if that changes, if the yeah, so initially it'll be 0, and but so on if no element exists, okay, count of key is 0 after decrement. So I'm trying to think of some edge cases where if the key does not exist, it's fine. Can I get empty strings? Should I handle that?
No, so
Okay,
basically, assume if you get an empty string, then empty string is a valid string. So
all
assume
right.
like that's a valid string you can check for. So if it's empty, just do
Hmm.
the rest. You won't have like null or anything.
Okay. So empty string becomes a key itself, and if the okay, guaranteed that the key exists. So yeah, off the top of my mind, I'm thinking if I keep a max key for okay, so if I do keep a global max key count variable, which kind of whenever increment is called, it checks if that key's value is going to be more than max key, then I store that key value in max key, and then I can return that pretty
Mhm.
simply. And same for minimum. If there is a decrement, it is tied to, but there can be a possibility where uh, increment. So, okay, I'm just making a small hash map to clarify it for myself.
Mhm.
Let's say we get ABC and we get eventually we have 22, and then we have XYZ, and eventually we have, let's say, 23. Now, in this case, yeah. So if I that okay, so what I was thinking might not work. So in this case, if I keep my max key as, oh, I've seen incrementing both of these strings, I've seen max count has gone to 23, so I keep that. And then min key is ABC, so ABC because, okay, I'll worry about the minimum key later, but I think this might not work out because if I decrement and I don't keep track of max key in decrement, then I'll have to either read through all the entries in my map because I can decrement 5 times and this becomes 18, and then my max key should change. But since I'm not tracking, then it doesn't remain O of one operation. So that might not work. So I'll have to fall back on something else. If I have I don't have to delete that. Okay. So instead of that, so increment is kind of an add function also if the key is not there. So I see an increment and I'm going to add it. So if I use so I'm thinking if I can use a priority queue, use a negative value and a positive value with priority queue and run with that, because then I get each function must run in O of one average time complexity. I think that satisfies, because if I have a priority queue, let's say a max, let's say min priority queue, because that's the default. If I do a min priority queue and I see whenever the ink is called, it doesn't, the contains key is false, then I add it. No, it doesn't matter that way. So after incrementing, I should add ABC and then 23 in case I'm incrementing to the queue. So I should.
So before you go too much down the priority queue, what's the time complexity of adding and removing to a priority queue?
It will be log of n for every
Right.
operation to add or remove.
Right. So that won't be O of one.
Yeah. So I was thinking if get max key is called popping off from priority queue, like just taking the top element is O of one. So I was going with that.
But ink and deck
That
will add things into it, right?
yeah.
So those won't be O
So
of one.
yeah, I mean overall, yeah. So priority queue won't work. Other than that, if I increment. Okay, so if I'm thinking that way, that I use increment to store my data in such a way that it always bubbles up the minimum or maximum to the top somehow, then I'm going to need. So there's a data structure. Looking for a data structure which can bubble up, which makes I mean it's hard to think something else than priority queue for that, but if I can just store the count. Nope, that won't work because I'm not storing the opposite of that. There is, okay, so if I store, regardless of how I implement it, but if I store it invertly, then I can have multiples here. Let's say EDF, because there can be multiples with that. And then I have XYZ. And then so if I store like that, and if this is so I'm thinking if a tree map, is that a thing? Yeah, tree map. If I use a tree map, it keeps things sorted for me. But okay, I haven't used tree map a bunch. But even if I use tree map and it keeps things sorted, I think the complexity still becomes O of log of n, because adding or removing things from it.
Yeah.
Oh, so adding, okay, wait, if I keep both the maps, then adding would be O of 1 and removing would be also O of 1 because I know the count. And
So you're saying you keep a
then,
map of the count and the inverse for both of these
yes,
things?
yes.
Okay. Then
So
how
in
do you
that
know the
case,
max and min if you just use normal maps?
so this will be this will be a tree map which keeps things sorted. Unlike the normal map, which
Okay.
unlike the hash map, which doesn't sort, it's just like order of
So
things
for
as
a
they come
tree
in.
map, looking up the min and max is still log, I think, right? And
Because
inserting elements is log.
yeah,
So I guess taking this tree map idea, right? You basically want things in a sorted order where you
mhm,
have a count and a bunch of elements, and then essentially you want to take something like if it goes from 22 to 23, you want to move
mhm,
it, right? Like that
yeah,
would be a one ideally. Like you remove from here and you move to here. I think in a tree map, I don't remember what operations are log, but definitely most of them.
yeah.
So
Anything which kind of works with a heap is log. So yeah.
right. So if you think about it, for increase and decrease, you're never jumping by like 10 or 15, right? You're only going up or down
Mhm,
one.
right.
So is there any other data structure we can use that will have things that lets you move things and maintain order and let you know like what's the min and what's the max?
Oh, wait a
That
second.
you might have to
So,
build yourself to give a hint, I guess.
oh, okay. So if I'm okay, so there's like two layers I can think of. First is that I keep the order of things as they come. How is there a maximum number of operations I can get for, let's say, increment?
So you can assume that like it'll be less than the size of an int or something. I don't think it's relevant to the
Uh,
question.
oh, okay, because I was thinking
Like you'll
counting
never
sort if
like yeah,
that
you'll
applies.
never
Yeah,
overflow. I think for
okay.
counting sort,
It has to
it
be 100 or something.
yeah. So
Yeah,
yeah. But basically
okay.
it's like, is there something you could have where it's like I'm in 22 and I want to move it down to 23. And maybe if 23 doesn't exist, I'll make it 23. And same thing moving back. So you essentially like move things from count to count. And then if your
Hmm.
counts are in a sorted order, then you could maybe have like a, front or whatever. And then you could say like, well, the front has to be the min, and then maybe you have like a back or something, and that's like the
Okay.
max.
Yeah, that is, yeah, I think that kind of clears it for me. It has to be a linked list, which is,
Mm-hmm.
I should have thought of linked list for OF1. But
Okay.
yeah, so if it is, if it is a linked list, then um, we go, okay, so if we start from the start, we have a front and let's go with front and back. It becomes, yeah, I actually called out cache also, and I've done the cache version of linked list, but I think
Mm-hmm.
of this. Okay, so the front, as soon as let's say nothing is there, front is pointing to back, back is pointing to null,
Mm-hmm.
and then we get, okay, so it will be a doubly linked list
Mm-hmm.
because I think I need direction, movement in both direction. Um, Now, if increment happens and the nothing is there, I would store, um, yeah, okay, thinking I would store. So I have two pieces of information. One is this and then ABC. And then I can have, that is it. And then if I have another and these things are similar, I can add it to whatever is in the back. So I add another. And then if it is an increment on the first one, I'll have to, so I'll store instead of okay, I don't know if this is not needed. So I still need a hash map, but instead of the number here, it will store a list node, which points to which points to the list, a linked list that I have
Mm-hmm.
here. Sorry, not here. Here, and this can have, yeah. So have one ABC doing, and then so yeah. So as soon as I get so if there is I'll go step by step now. I think I got a handle of what I have to do. So if I get increment call for ABC initially, I'll add a entry to hash map and another entry to hash map, and then sorry, I'll add an entry to the linked list, and it'll be in front of or whatever to the back of the list. Uh, when then I can have another, yeah. So add to double linked list, then uh, add to hash map
Mm-hmm.
the node, and then if I have another, let's say it's fourth in a DEF, same thing. So I'll just call it link DEF. Then I get a, let's say, inc ABC again. And in this case, I'll fetch the, yeah, I'll fetch ABC from the map and increase the count and then see if the next run. So if I want to, I choose to keep this in increasing order. And that means is if this becomes 2, if anything changes here,
Mm-hmm.
uh, in case of increment, I'll check the next value, like on my right,
Mm-hmm.
and see if it is, if the value is more than that, I'll kind
So
of
let me
try
call out
to,
something really quick just to help you along
yeah.
here. So let's say I have a bunch of these. Let's say I have like 1,000 of these items with one, right? So I have like one whatever XYZ, right, and so on. So I can have like I can have a bunch of duplicates, right? I might have like 500 items with a count of 1, 500 items with a count of
Mm.
2, whatever. And yes, you can access it in O of 1, but it's going to get really annoying to know like where does this go, right? Because this might have to move down like 500 items. So how can I make this
Uh-huh.
better so it's very easy to move things along instead of having these like things like this? Like, is there an optimization we can make that we know like how to move it and not keep
So
track
yeah.
of like, where's like where's the first 2, where's the first 3? Like that's just gonna get pretty out of hand.
Oh yeah. Um, so okay. So if I know where the first, so because it is incrementing by 1 every time,
Mm-hmm.
it will be it will be so if increment is called here, I just want to know where the 2 is in the list or
Right, and that's going to
which
be kind
node
of a
start.
pain if you have them all separate. So, is there any way
Ah.
we can change
Oh, okay.
this design of this list to make it easier?
E, okay, yeah. Um, so I removed that, but if I go back, okay. And so one is to uh, change the design of the list, and one is to maintain a. I'll go if I go back to my map of inverted map of keeping count and the list of things. Then I just need to look up which node is there for 2,
Mm-hmm.
and then then I can just add a node next to it and kind of append it. So if I have a hash map where I know that 2 is uh, again something PQW,
Mm-hmm.
then I can, yeah. So I'll know that this is actually a list node, uh, a list node PQW. So I have this, then I can fetch that node and just add, remove from here, and wherever that PQW will be, I'll add it to that.
I
I
see. So you're
guess
saying
I
like
can,
in like your well, this is a hash map, right? This thing.
yes.
So you'll have a hash map for like you'll have a hash map in every node. You're saying,
I'm
or I'm
thinking,
confused. Yeah.
yeah, no, I'm planning to keep the hash list of list nodes so that uh, I'll just take whichever one. That's not a complete thought. Um, so
Like basically, what you
okay,
want to do is I guess to give you another hint, how can I
it-
combine all the items that have a count
yeah,
of like 1, and then
yep,
that way I
yeah,
know, okay, here's all the items from the count of 1. I just need to pull out what I need and then go to the one with a
yeah.
count of 2.
Right. So, so this list node is basically, uh, yeah. So, okay. So this becomes like a list node for 1, and every
Mm-hmm.
single string which has a 1 count stays here,
Mm-hmm.
and then 2, and then all the string stays here,
Right.
and that way. So then when I need to, okay, so I'll just store this particular list node. List node of 2 will have
Mm-hmm.
all the strings that have value of 2, or what is
Mm-hmm.
it? Yeah, the value of count as 2.
And now if I need to know like where's ABC, how are you going to store that? Like if I'm like increment ABC,
Yeah.
this is no
So,
longer
oh,
its
yeah,
own
yeah.
node.
So I'll,
So how would I
right,
do it?
right. So this will become this will point to the node, like I can, so I either I have a utility function which fetches or which gives me back whichever node,
Mm-hmm.
the node for that count. So in this case, I can do like of count, let's say 2. So in that case, I know that ABC is in here.
Mm-hmm.
Um, and then I just like either remove it from the set if
Mm-hmm.
there is a set here, and if not, I'll if in increment, I'll remove it from the set here if there is a node for 3, or if there is a node next to this node, then I'll create one and add it to that set. Otherwise,
Mm-hmm.
I'll keep it here. So
Okay.
that.
Okay. Yeah, so I think and now I guess it's kind of obvious how you would get the min and the max, right? So can you talk about that a little bit? Like if I get called get min or get max?
Yeah, so because it is increasing order, next to left of front will have the
Mm-hmm.
minimum, and sorry, right of front will have the minimum, and left of back will have the maximum.
Yep.
So I'll keep, it's
Okay.
about manipulation that, yeah,
Okay. Yeah, I
we'll
think
have to
this is
take care
good.
of.
Let's get to the coding. So we have about 25 minutes. So let's get a
So,
solution.
okay, so I'll have to implement all one class. Okay, so I haven't done a like class level thing in CoderPath, so I'll just create a separate one and hopefully that works with
It
the
does work.
existing.
Yes.
Okay,
Yes.
class all one. Then we have,
In your
so
main, if you make
increment.
an instance, it will work fine.
Okay, cool. Increment doesn't have anything to return just inside. Okay, increment
Nope.
decrement doesn't return anything. So void see something here. One, two, then we have void and get. Oh, sorry, not void. Then get these. Then we have. I'm just boilerplating it here. So I'll move faster later. Okay, that is fine. Yes, you run front dog, right? I haven't created it, but I'm not right. And any, so max keep one of the keys. So run dot right, and then I can say dot. Okay, this will be something I'll have to process for edge cases, but right, and this will be right dot right.
Mm-hmm.
Next is setting up the linked list. Oh, normally I use a separate class for linked list.
Yeah, you can do whatever is easiest for
Okay,
you.
right now this node gives me nothing. So in this case, we had count equal to 1, and Okay, and next now, and there's a set of keys. Do well, so, okay.
Okay.
Sorry. And we have set string roots, and we have count, and we have sorry, not next, it'll be left, and right. So this changes things, and so there's a way. This would be better if it has. Okay, list node doesn't need to have that. It's my helper function needs to be there. So let me create a helper function. Says void add to front. No, add to last.
Okay.
And that will take a string key, I think. Yeah. No. Okay. String key in case I increment and I have to. So it's not add to last. It's actually okay. I'll come back to this later.
Mm-hmm.
Let's start with the members here. This node, there's a front, and then there is a back, and then we have all one has nothing. So by one front dot right is equal to back, back is equal to this node. Oops. Right. Yeah. Then it is no count. Leave that for now. Then and I'm not sure what I'll do with count right now for in constructor, so that's fine. And it is a new is now empty. Then I would just want to say front dot right is back, and back dot right is equal to now, and back dot left is equal to 1. So this sets up the list. Just keep track of what I'm doing.
Mm-hmm.
And somehow do this. Okay. Why not add this also? It doesn't matter really because it is now already. Actually, this won't matter also. That's fine. Okay. So we have these. Now, if there's a hash map I'm missing. Map. Now we need. Wait, what was I thinking? So if I, this node of count, right? So it's a string. And I'm going to list node. Call it map for now, and then come back here. Map is equal to this will then allow me to inc is string key. So as soon as key comes in, now first step would be to check if map contains. So if I do quickly map contains key, then I get map contains key, and then I get if I get that, I need a way to. So first, get the node from map, and then I'm just trying to keep separate. I'm trying to separate out the steps that I'll take. So get the node from map, removes key from node, and then I need to get the node for count +1, which should be fine because it should be next of this node. Okay, yeah, that is node dot right and increment. Yeah, okay. So okay, I'll just do this quickly. It's short on time. Node gives us what was it? Map. It's a temp. What is temp is equal to map dot get key. Okay, and this node target is where this is supposed to go is right. Just storing it here. Now in temp dot what was I saying? Keys dot remove key and then keys and then temp dot right and target dot keys dot add the string. Okay, so if I get off these. Okay, so this is good for that. Else I need to make sure that I can add stuff. Oh, if it doesn't exist or if it is back, and count for that. So if temp.right is target, and if target is not equal to back, yeah, then do this. Else what we want is new this node. So this node is equal new node is equal to new node, and then okay, the new node. This is just initializing a new node. Dot count is equal to temp dot count +1 and new node. Sorry, new node dot keys dot add key. Actually, this remains same, so I can make it a little bit cleaner if I do this here. Remove this thing from else and dot sorry, new node. Oh, shit. This was fine. I don't need to do all that. So yeah, this takes care of if the last node is back, increments if nothing exists in the map, then I kind of follow the same thing like this. But in this case, there is no temp count, so it will be 1. And for the new node count keys that add key. Now, okay, so now I need temp. So this node temp is equal to front dot. So this is where I kind of insert in between front and back. So I need front, right, and then then this front right, front dot right, a little bit new node, and then new node dot right is equal to temp. Is that so? Or I don't need that temp. If I know that nothing is in the map, I can just insert it between front and. Okay. I can just insert between front and back. But this is more foolproof, I think. Yes. And new node dot left is equal to front. Okay. Once this is done, I think this is good for incrementing. For decrement, also I need the same logic of if dot contains key. Oh wait, the constraint said that guaranteed that the key exists. So
Mhm.
I'll keep this check. I will keep this check, but I'm not going to write the else condition here. And just why bother? So in decrementing, the key is there. So I get this node. Oops, sorry. This node. This node key is there. Decrement. So yeah, source, I guess. Source will be dot get key, and then the destination would be left of source. So this node information is equal to source dot left. Correct. Okay, so source dot keys dot no key and destination dot left. So if again the same thing, if destination is not equal to front, all is good. We do destination dot remove. Oh, sorry. Dot add. Dot keys dot add. Keys dot add key. And if it is gone, or if it is front, then I need a same thing basically. So I'll call this out here. So if because it was back, I created a new one. I added a key, but I didn't add anything after that. So missing 7993, and I have to add the target becomes temp.right. So the target is that, and keys are added. So I'm trying to trying to remember if target or temp.right. Yeah, so temp.right becomes this new node. Temp.right is equal to new node. I have to switch again. This node. It is back. Okay. So it was back. Now temp.right is new node. New node dot right a little bit back. And left is equal to temp. Then we got this and here. So okay, coming back to our thing. It's almost similar to this, but instead of back, it'll be front. I think I can copy paste most of this code. Source, this new node, source dot left, and right is left in this case. And right is source front. Okay. So that takes care of that.
So let me ask you real quick. So basically, the reason you're saying that you can go left and right, that the nodes are always going to be there and always going to be that node plus one, because when you're moving things and that like count becomes empty, you're not removing it, right? You're storing it. So that's why it'll always be in incrementing order, right? So like if I have a count that goes from like 1 to 2 to 3 to 4, and then maybe back, I will still have all of these items. They will just have nothing in them, correct?
Yes.
Okay.
That is correct. Oh, I'll have to update the map as well. That reminds me. because once I'm checking from the map, I'm not changing the map with that thing. So at the very end, once I create the new node or target, map.getKey changes to temp dot. So now we will have, in this case, an increment. Yeah, temp. Okay. So I just need another line of add should be or map.put on that key, and on that key the new node. So temp dot right in case of increment. Wait, do I not have temp? Oh, it's inside. Yeah, two different tips. So,
Yeah, you have a temp and two different ones, so you don't have access to it.
Right. Okay, I can count this as source as with decrement. And it's quick search and replace here, 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 and here. So this should save my map. It is inside that if condition, that's why.
Okay.
Doesn't matter because it will go inside one of these things.
Mm-hmm.
Increment SRC is if map dot contains key, then you can map dot get key. Otherwise, it will be null. So this changes that, but I think this makes sense. Yeah, then I have that. I don't need that now.
Okay.
Okay, so this works for me. And then decrement up to full similar move. Why? Okay, so
won't in the else case it will just be null? So then you're basically saying put key null, like there is no SRC here, right?
Oh, right.
So do you need this temp to be SRC or something?
Yeah, I'll just put it inside. I was trying to see if I can like pull it out of the if else conditions, but I can't. So I'll keep it inside and keep everything within the if else condition. I don't like that design per se, but can't think right now. So it should be that.
Okay.
That's right. Yeah. So same thing I have to do here, which is map dot. And it's easier here because I have sort of left then. Yeah. Okay. That takes care of that. Now here, if I've done everything currently, all I have to return is front dot right. Back dot left. Back dot left and dot right. Yeah. I don't need this thing, although this would help add to last or things like that. Yeah. So dot keys and then get. I want to fetch any one of them. So yeah, I'm trying to see if there is a simpler way, but nope. So okay, so 2 array and 0 should be done. What's all this? Okay, I'll just fetch this out or string array is equal to keys dot fly dot keys dot to array.
Keys to array.
There can be
so
because it's a set.
Yeah, so it's a set. So do you know how you can get an element out of a set faster? Like you just need any one, right?
Yeah. Blanking. So I was expecting a get method within set, but it's not there. So
Yes.
um, any other way to get it fast would be just. I mean, it's not a stack. I can't pop from it. I can't. Uh,
Yeah.
yeah.
So what happens when you do this? Or whatever, right? Like bar item in my set. And you
Oh yeah.
just
I mean,
like return here.
first one. I thought we. Uh, I mean, I thought it was only for a list or an array, but yeah, I can. I can do that.
So how does this work under the hood? Do you know? Like, does it make an array or what does it do?
Iterator. I think it creates an iterator and then it
Mm-hmm.
goes one by one within the
Mm-hmm.
collection. In this case, that being set.
Mm-hmm.
So yeah, I can use that iterator. I guess.
Okay.
So bring this one. Uh, one dot cloud dot keys, and return this one.
Okay.
And yeah, so return blank because it's okay. So is that so? I'm just saying that returning an empty string was a kind of if no element exists, but we
Yeah,
also
we'll just
discussed that
say
empty.
you never
Okay,
get an empty string as an input because that's true.
okay,
So
yeah,
that's
okay,
fine.
okay. Same thing for here, and okay, that
Okay.
okay, and this will be just black dot. Okay, that's yeah.
So we're a few minutes over, so let me just take over and ask you some
Sure.
stuff. You don't need to code anything. So
Okay,
okay, so number one, so basically you said, let's just go down here maybe, and this will just be like what I think is wrong, and you can tell me if you think it's right or not. So let's say I have
okay,
an element and it increases the count, right? It goes from 1 to 2 to 3 to 4 to 5 to 6, and then maybe it goes back
yeah,
down to 1. Okay.
yeah.
So I only have one element, right? And it's here, correct?
Hmm.
Now when I do get max, what will happen in your code?
Oh, yeah, I see. Because things are empty, but still the node is there, so it'll return an empty string
Yeah, so without
because the back
changing
is
the
still alive.
code, how would you fix it to uh, make sure that
I
doesn't
have to,
happen?
yeah. So when I remove keys, I have to delete the node and then plumb the either side of the node together.
Hmm. So let's say
So
we have another case. So that makes sense. Yeah, basically you're saying like I'll delete like when I'm deleting, I'll be deleting like this, and I'll have the right thing, right?
yeah, and front and back needs to be plumbed. Yeah.
Cool. Now let's say we have something like this, right? So it goes all the way up to 6,
Hmm.
and then I insert a node with count 1. Um, right.
So yeah,
So in your code
just
here,
uh
if you plumped, it wouldn't
yeah.
go. It would go from 1 to 6. So you can't just be like just go over here, right? So how would you handle that?
You mean to say that if a string, sorry, if the string with value 6 is there and nothing else is there, right?
No, no, no. Okay, so basically, let's say I insert a string. Okay,
Hmm.
it goes from 1 to 2 to 3 to 4 to 5 to 6.
Yes.
Now these have nothing.
Yeah. So I remove them.
Now I
Yeah.
insert another string, so it'll have count 1. So
Right.
this is my list. Now if I
Yes.
take that string in 1 and I add the count, it needs to go to 2. So I can't just like
Yeah.
move it over here, right? So how would I
Right.
handle that?
So when I was, so what I did
Because right now you're
was,
basically saying just if the next exists, go to next. So that wouldn't work because the next would be 6.
right. So, correct. So in that case, I shouldn't be going to the next. Along with going to the next, I should check before, like before traversing, I should be checking if the next has the value, has the count that I'm looking for. So
Hmm.
there are that, yeah. And if there is not, then I'll have to insert one.
Okay.
Again, plumbing through. So I think I need two utility functions, which are like remove from this, remove from right and
Hmm.
remove from index kind of thing that is like isolated function which can do this job.
Right. So you're basically like removing from an index and maybe like adding to an index or something.
Yeah,
Okay.
yeah.
Yeah. So that's why I asked you like how you know these are there so that that does make sense to know this, but then yeah, your min and your max would be broken. So then I think you have to do the plumbing, and then that would kind of fix everything. Let me see if there's
Right.
anything else. Inserting something. Yeah, so I think the rest of it you can kind of figure out. Like if I have a node of count 6, if I do the plumbing and I need to insert a node with count 1, how would you do that?
Mm-hmm.
Like I have this thing and I need to insert a new node. How would that happen? So I have a head here, and then 6, and then
head
a
would be.
tail.
Are you asking a general LinkedIn question? Because if the head would be pointing to 6, right, and
Yes,
then 6 would
exactly.
be pointing.
Yeah,
Yeah,
so
yeah.
if I'm inserting a node, what would that look like with the changes that you're saying, basically? Like what are the steps?
Oh yeah, if inserting a node, then it will not be in the in our map first of all,
Mm-hmm.
and then if it is not in the map, I'll take the head
Mm-hmm.
and try to add a new node there, because I know it's whatever is in the list node is not going to be. I mean, 1 is not there, so 1 is
Mm-hmm.
the minimum this list can have. So I can rest assured and add another node to my head.
Okay, cool.
And then yeah.
So I think that's most of it. I think that those are your main issues. Is your like this wouldn't work because you didn't account for like this thing. You had some other small things like or actually, so you set the count to 0. No, I guess that's fine, right? You set the count to 0 because you're like manually editing the count everywhere else. So that should be
Yeah,
fine.
I was. Yeah,
Okay.
and I can. Yeah, I should have. I didn't spend too much time on what the default count should be, so I just
Mm-hmm.
moved that logic to when the manipulation was happening.
Okay, cool. Okay, so let's do feedback. So I think for this
Okay.
problem, you restated the problem. You asked about the constraints, which is good, and then you mentioned a lot of items. And so it would have been good if you like the items you mentioned. I had to kind of eliminate them for you. It's like if it's a 1, you can't use a heap, right? Like so you can just mention
Mhm.
that if you want to. You could be like maybe a heap, but heap is log, so that's just out. Tree map, same thing.
Mhm.
So then there's
Mhm.
like not too much other stuff, right? It's basically like I need to maintain a sorted order in O of 1 moving. So you basically need a tree map without a tree map, essentially, right?
Yeah.
So it would have been good that if you would have pointed out linked list yourself. I do think
Right.
this is one of the harder ones to figure out like what to use. It's not obvious. And it's good that
Mhm.
you figured out like some people, I think including myself actually when I got asked this problem, just say like a map or something.
Mhm.
And they don't realize
Mhm.
these edge cases and you pointed them out, right? If I have like 18 and 22 and I decrease it, it gets all screwed up. Also, if I have a
Yeah.
count of like 6 and 1, and I get rid of the 1, now my minimum max is 6. So there's like no way you
Mhm.
can efficiently get the min and the max without a sorted data structure. What gives you a sorted data structure linked list?
Right.
So definitely would have been good for you to figure that out. So I basically gave you a like a lean no hire for the DSA because I gave you a lot of time and I
Uh-huh.
kind of said like some of these things don't work, and then I had to give you a decent amount of hints to for you to figure
Yeah.
out the best linked list.
Yeah. That was basically the answer. So I
Right.
understand.
Right. And then so you kind of figured out how a linked list works, but even then you did it like in a pretty inefficient way because if you store items
Mhm.
by themselves like you had here in 45, you'd have to keep
Yeah.
track of like where the next number is all the time, and that's going to be like maybe it's doable, but it would be very hard if you have a bunch of items with the same count. um,
Mhm.
so then I had to kind of point out like, oh, you can combine it into a group, and then that would make it easier for you. I think once I pointed out that you can combine to a group, you realize like, oh, I could have a set, and then I think the rest of it was pretty good. um,
Okay.
and then so for your coding, yeah, it would have been good to realize that like your functions are broken. And I think for mid to senior, especially for senior, like I think this would be
Mhm.
like a lean no higher because for the coding, because like essentially half your functions don't work. Um,
Mhm.
so small things, but you want to realize like, okay, when I move things, yes, the next node exists all the time, but now I have a bunch of nodes that are basically empty and like are invalid. So I need to figure out a way to
Mhm.
get rid of that. The other thing I was looking for in the coding that you kind of mentioned, and that would have been good, I think for these like design problems, it's really good to see like how can I take everything shared and put it in utilities, because then the code becomes a lot easier to write and to test. So
Right.
it would have been good if you had like a, like move or something, or insert and remove or something, like insert to the right, insert to the left. Like you can think about how you can modularize it, but you could modularize it. And I think for coding interviews, a lot of people are like, I will just never modularize because it's a coding interview, like this isn't production code or something. But once the thing gets complicated enough, like it will save you time to modularize it. So that definitely would have been good, and I think that would be like some of the things I'd be looking for like higher level. If you were like intern or new grad or something, like a lot of people will just plump like 50 lines of code into one function, like whatever. But you should recognize, hey, I have these common things. Like in my decrement and increment, I'm basically doing the same thing. I'm like taking a thing and moving it left or to the right, and it's all the same, right? If the node doesn't exist, I'm whatever. And then also in your if else's, it could be like very similar. I think modularizing helps for not making mistakes, because you could focus on like, okay, I'm doing this one utility. Does this work correctly? And then when you have these like I think this increment and decrement are reasonably complicated, especially since you miss some stuff. And it's very hard to like write the whole thing and have no mistakes. So definitely that would have been good. But the nice thing is like, you are familiar with like how to write things in Java, how to like do stuff in Java, how to use data structures in Java. So that was good. The other thing that could have been better is it's kind of confusing to have like a source and a TMP and stuff. So I'd basically almost never use a TMP. Like think of better names to use. You want to make things really obvious, like what's going on. Like maybe if TMP means the node it's going to, you can say this is like insert location or move location, something like that. It's going to help you, and it's also going to help the interviewer like understand what's going on a lot better. And then let's see. Yeah, I think the rest of it. Oh yeah, the iterator thing. So this is more of like, how well do you know the language? I guess let me ask you, is there another way you could do this now that you know you can use an iterator?
I haven't used iterator a bunch of times, but yeah, I can create an iterator and then just do a has next and then next from there instead of the for loop. So
yeah, exactly. So you could say like, if the head next is tail, then there's nothing there. Otherwise, you can basically do like front, right, iterator, next, and you can just return that. And then that makes more sense than this, because this is kind of like hacky.
Yeah.
So that would have been good also, like to know how to. I think I actually got asked this thing in like a Google text screen or something a really long time ago. Like, oh, I have a set. I need to. Well, it was like part of the question anyway. I have a set. How do I get one element? Then I was like, well, there is no like. I think there's a pop, but you don't want to pop because you like get rid of stuff. I think this is in Python, and there was no like front or or like index access. So it's good to know that like you can have an iterator and then you can just take an element. And that's like the cleaner way of doing that thing. Yeah, so overall I would say this would be like a lean no hire. But yeah, this is like a reasonably tough problem. I think it's hard to figure out what to use. I think this one is a good one to test. Like, do you really know data structures? Because there's like a lot you can do, and the one you need is like pretty complicated. It's not just like, oh, it's a heap. So there's definitely some improvements that could be made there. But like like data structure, like time and space complexity and stuff. And then this one's also kind of a good implementation one, where it's like there's a decent amount of edge cases. It's non-trivial to code. So that's why I was like, I never asked one before, and I was like, how long would this take? And I think this would be a good one to ask for like mid to senior, for like a full 45-minute or 45, 50-minute. And I think there's quite a lot to write and quite a lot to think about, and definitely shows me like a lot of stuff. So I think
linked list always.
Oh yeah,
sorry. I know. I was just saying, linked list always gets me with the edge cases. So exactly the things like this. Yeah. So
for sure. I think this is definitely non-trivial. So you can try this one again. You can also try the other hard one that's like the LFU cache.
Yeah.
There are Java tricks. Like if I said you could use a tree map, this would be significantly easier, I think.
Yeah.
But that's why I said you couldn't. So.
Oh, fun. Yeah.
Yeah. And if there was no constraint, I would definitely, that's the other thing. Like if you're familiar with a tree map, so basically I use a tree map in some of my questions, but you want to be familiar enough to be able to code it. Like if you're like, I've literally never used a tree map, then I would just do the linked list, because you don't want to make a class and be like, I have literally no idea what it has, and I have to look up the entire thing. But that might actually be even slower. And I've had people do that for like C++ or something. They use like some list node or whatever, and they literally didn't know how like any of it worked. So I would definitely
Oh,
discourage you from using things that you've never used before. But if you are a little bit familiar, then it can definitely make things easier for you. And you can point that out if you want to. You can be like, hey, there's probably some complicated linked list thing, but I can do a tree map. This will be, log n if there wasn't that one constraint, and then that would totally work, and it would be like kind of simple. And I think for any
right,
kind of
right.
like cache or like a sorted structure, there's there's
Mhm.
a decent amount of hard problems that you need like a permanently sorted structure. I think that's where you can use a lot of cool stuff in Java, like tree map, tree set, linked hash set. I think link hash set is basically like a set, a linked list, and a hash map. So if you're like
Yeah,
familiar with that kind of stuff, you can definitely throw that in. I think it shows like
right.
that the language, more advanced stuff other than like or how to write it like a basic for loop or something.
Mhm,
So for
mhm.
those kind of things, I would usually say like, here's what I'll use. Are you cool with this? And then if they want you to do it from scratch, they'll tell you. Otherwise, feel free to use that kind of stuff.
Okay. Yeah,
Yeah.
I'll keep that in mind. But yeah, I'll work on this too.
Okay. So if you want to ask me the system design stuff, happy to answer that.
Oh yeah. So cards on the table. I have an interview coming up tomorrow.
Hmm.
This is with Life 360. I did pass the technical screen. It was very like kind of easy question in my
Hmm.
opinion. They didn't even want the optimal one. They wanted the suboptimal one for some reason. But
Hmm.
that's fine. And this and there are like three interviews, and their description or their heading that they have chosen kind of overlaps with each other. Because so okay, the first one is domain-driven design,
Hmm.
which I understand how the framework is and what it does. Like what they expect, I understand that they expect more conversation than whiteboarding, and they want to know that I can communicate without the technical jargon. But
Okay.
then the second interview is termed as concurrent system design,
Hmm.
which I would assume which would come under like when I'm discussing about a product or a domain, I would discuss how the traffic will be there and all that. So
Hmm.
it kind of makes me think they are the same thing. So what are they expecting in the second interview? I'm not sure. And the
So
third one
okay,
is
go
yeah,
ahead.
and the last one is I'm completely clueless. And the last one is methodology on build quality, if that makes any sense.
I literally haven't heard of that before. If they
Okay.
had any, so as far as like the concurrent one, like first of all, I don't know what it means, but if they mention like concurrency, I guess I would think of some things that like if it actually means concurrency, I don't know if it does. I would think of like how do you handle like concurrency in a pod, and then how do you handle concurrency across different servers. Like let's say you have some kind of thing that like you need to block or whatever and other servers can't access it. Like how do you do
Uh-huh.
that? And then also, if you have a bunch of like things in a server, how do you speed things up? So I'd be familiar with, I don't know if this is in Java or whatever, but I'd be familiar with like concurrency in Java, how to make threads, how to like have structured concurrency. I think there's structured concurrency in Java, right? Um,
Yeah, but
so
they,
things
they
like that.
mentioned that, but they're also saying don't go into implementation and be more conversational or
Yeah, so
things
I
like
guess
that.
so I guess you don't have to talk about like how to do it in Java specifically, but
Java,
you
yeah.
should figure out like, okay, I have this thing. Uh it takes a long time. How do I split it up? Maybe not in Java, just like overall. How do I make sure that
Uh-huh.
like everything works in the right way? And then yeah, I think the other thing is the multiple if you have multiple pods for a server, how do
Okay.
I if I have some resource that like needs to have a lock or whatever, how do I do that kind of stuff, like have like distributed locking. I mean, this is super vague, but those are some of the things that I
Hmm.
would think about. So
Okay.
things like that. Honestly, I could be totally off because I've never heard of most of this stuff, so maybe you can
Hmm.
ask them for clarification, like yeah, if you
Yeah.
wanted to give me like more details or whatever, then like I could figure it out maybe. But yeah, honestly, it's just
Uh,
like, here's a super vague thing they asked me, what do you think it means? It's like hard for me to say, right? So
yeah. That's why I mean it's vague for me also, and the recruiter didn't help really with any of these. So
I think
trying to
usually the way
figure
I
out.
go about things that are super vague is like I study the normal stuff and I'm like, okay, this is outside of my control. I'm just going to study the normal stuff. I'm going to do the best I
Okay.
can. I'm not going to try to
Right.
guess random stuff and hope I'm right, and I could be totally off. I think it's just a waste of time. So I did have some
Okay.
interviews that were like there's basically no prep. Um
Uh-huh.
and then so actually my Apple interview was kind of like that. There's like, you'll be doing some stuff, good luck, and I was like, cool. And I think
Okay.
the thing you can do there is basically just like prep the general stuff, and then you do as well as you can. And you
Okay.
don't want to spend a bunch of time trying to guess what it is, because like who knows, right? You can
Yeah,
spend a bunch
yeah.
of time guessing one, it'll be the other. It might even make things worse because you over prepare for something that you thought it was and it was something else. So I would just prepare generally, and if it's like if you got it type of thing, and you'll figure it out, you know. And if you don't,
Okay.
it's super
Okay.
hard to prep, so there's no reason to like burden yourself like crazy over it.
Right. Okay. Yeah, that was it. Thank you.
Okay, cool. See ya.
Yeah. Okay. Bye.